Hello, third grade teachers. Today, we are going to take a look at Unit 6, Fractions as Numbers. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 6. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and the IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Let's take a look at Unit 6 for third grade, Fraction as Numbers. This unit has 1 AKS and 4 IOAs. All parts of this AKS and IOAs will be taught in Unit 6. Just as a reminder, at the end of each AKS or IOA, in parentheses, you will also see that we have the state coding that you can reference if needed when you are searching the Georgia DOE website for resources. Unit 6 is where students will learn to read and represent fractions. The goal is to help students use visual models when working with fractions with denominators of 2, 3, 4, 6, and 8. Representations will include area models, linear models or number lines, and set models. This is the first time students will be introduced to fraction notation as a way to refer to parts of a whole. Let's look at each IOA that will be taught in this unit. In IOA 4A, students will represent unit fractions and non-unit fractions using area models, parts of a set, linear models, and points on a number line. When working with parts of a set, the set size should not exceed 24 objects. It is also important to remember that this is the first time students have worked with fractions on a number line, because this is the first time students have really worked with numbers less than 1. In IOA 4B, students will compare unit fractions using visual fraction models. Students will record those comparisons using greater than, less than, or equal to symbols. In IOA 4C, students will build on the background knowledge of representing fractions less than 1 using area models, set models, and linear models, so students can investigate fractions greater than 1. Students will recognize that fractions greater than 1 have numerators larger than the denominators and can be written as mixed numbers. In IOA 4D, students will recognize and generate simple equivalent fractions. The goal is for students to make sense of equivalent fractions using those visual representations. Students will also express whole numbers as fractions. Finally, you will see that this AKS has 2 extension IOAs. The new extension IOAs are there to support the differentiated needs of your students. As you can see, the word extension is bolded and in parentheses at the end of the IOA to denote that they are extensions and are specific to Gwinnett County. Please note, you will not find these resources from the state of Georgia for these IOAs, and they will also not be found on the pacing guide. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Now let's take a look at the pacing guide to see how the AKS and IOAs have been paced over the course of Unit 6. Here is our pacing guide. In this box, you will see the name of the unit, the big ideas for the unit, and the suggested pacing. Unit 6 will focus on numerical reasoning. The suggested pacing for this unit is 5 weeks. In the next box, we will see the AKS and IOAs that will start the unit. Unit 6 will begin with AKS 4, IOA 4A, and IOA 4C. Remember, the left-hand side of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objective for the day, as well as suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objectives for each day of instruction. Some days, you will see instructional resources linked for the numeracy components of a traditional teacher-led lesson. On other days, you may notice a task-based lesson, which is your full numeracy block on that day. You will also see resources from the Georgia DOE website, along with lessons from Georgia Reveal, our newly adopted resource. We will begin Unit 6 with IOAs 4A and 4C for a suggested pacing of 16 days. These IOAs will help students to understand what a fraction is and what models can be used to represent those fractions. The unit begins with a focus on unit fractions. Remember, the only denominators third grade students will work with is 2, 3, 4, 6, and 8. The first few days of instruction are anchored in the types of models students will use to represent fractions, such as area models, set models, and of course, our linear models in number lines. Then, students will begin working to represent non-unit fractions less than 1. You will notice you will spend 2 days on each type of model. Again, area models, linear models and number lines, and also set models. It is important that students learn how to partition the whole and reason about the size of each piece. The use of fraction manipulatives is highly recommended throughout the unit, as well as pairing those manipulatives with a drawn representation. After students spend numerous days representing fractions less than 1, students will move into representing fractions greater than 1. Again, we will use visual models such as area models and number lines as we learn that the fractions can have numerators greater than denominators, and how we can also represent these types of fractions as mixed numbers. After building a foundation of ways to represent fractions, we will move into the next 2 IOAs for the unit, IOA 4B and 4D. Remember, the left-hand column will guide your instruction with regards to learning targets, models to use, manipulatives to reference, and the learning progression of these IOAs. This part of the unit will begin with a few days of comparing unit fractions. The only types of fractions third graders will compare are unit fractions, fractions with a numerator of 1 and only denominators of halves, thirds, fourths, sixths, and eighths. We will spend a suggested 3 days on comparing unit fractions. Then we will move into recognizing and generating simple equivalent fractions. Students have already begun to spend some time learning about equivalency when working with fractions equal to 1 whole throughout the unit. But we will begin this IOA with a task-based lesson to understand equivalent fractions. you will see that this IOA was planned to cycle through the different types of models, just as we have through the entire unit. The models will again include area models, linear models, number lines, etc. So it is very important to pay attention to those bullets on that left-hand side of the column. Georgia Reveal lessons are also included throughout the unit or have been adapted to align with our AKS. Again, as you work with students to recognize equivalent fractions, generate fractions, compare fractions, it is important to remember that students are only to work with fractions that have denominators of 2, 3, 4, 6, and 8. Just a note to pay attention as you are looking at resources. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or the ATS, for guidance on additional strategies for each IOA. Hey teachers, we are going to take a look at some instructional strategies to support AKS 4 and IOA 4A, describing a unit fraction and explain how multiple copies of a unit fraction form a non-unit fraction, and use parts of a whole, parts of a set, and points on a number line, as well as distances on a number line and area models. So we're going to touch on a few of those today. And we're going to use this problem to get us started. And with this problem, we're going to first look at using area models and linear models. So these are the two parts that we are really looking at. So those area models, and then also points on a number line or distances on a number line, which are also called linear models. All right. So here we have this situation. Cooper had a sub sandwich that is 1 foot long. He wants to cut it into 6 equal-sized pieces so that he can share his sandwich with his family. How might Cooper cut his sub sandwich into equally sized pieces? And what fraction of the sandwich will each family get? All right, so a couple of things that we're going to take a look at when we're considering this situation and working with fractions. So one thing to consider is the fact that we are working with 6 equally sized pieces, okay? That's one part that I need to note here. 6 equally sized pieces. We also know that we have a sub sandwich that is 1 foot long, okay? So that sub sandwich, this is representing our whole. Okay, that's our whole in this situation. So we always want to think about what is the whole, what's representing the whole, because it's not always a sandwich. Sometimes it could be a pie, sometimes it could be a pizza, sometimes it could be a mile. So you always have to think about what is my whole representing here. And so it says that we want to cut and share the sandwich with his family, and we want to cut it into equally sized pieces. And I'm looking for the fraction of the sandwich that each family will get. Okay, so if I want to cut it into equally sized pieces, one thing that I could do is use my manipulatives, and I could take my fraction tiles, and I would have my 1 whole. And because I know I want 6 equally sized pieces, I want to partition the whole into 6. Okay, so there we have our 6 individual pieces, and I usually like to represent those fraction tiles in relation to the whole. You could also, or fraction bars, I think those are technically called fraction bars, fraction squares, or no, I'm sorry, fraction bars or fraction tiles. This would be your fraction squares. Okay, so technically this doesn't look as much like a sub sandwich, right? This kind of visually looks more like a sub sandwich, which might be why I use that manipulative rather than the fraction squares. However, I have my reference to 1 whole, that's the blue piece, and I've got 6 equal size pieces, because that is especially important to know that we're partitioning a whole into equal pieces, and I need to figure out how many equal pieces. And of course, this one really doesn't apply because our sub sandwich is probably not circular. However, if you have a pie, if you have a pizza, things like that, you can also use your fraction circles. I do like that they're actually the same color here, so that's a good reference for students. So some situations you might be able to show both, okay? So those are the manipulatives that you can use to help support you throughout this unit. So here I've got our manipulative model, our fraction bar, where I have my one whole sub sandwich and I'm partitioning it into 6 equal sized pieces. So what fraction would the family member get? So what if I was doing this representationally? Okay. If I wanted to draw my area model, I could draw a rectangle to represent that sub. And again, this is my one whole. Okay, so that's my one whole. That's the piece that I need to partition into 6 equally sized pieces. Now, a couple of different ways that I can partition into 6 equally sized pieces. I know that the number 6 is even. So one thing I know about the number 6 and being that it's even is that I can equally start partitioning my whole in half. Okay, so I like to start here because then that helps give students a reference. So here's each half of my sub. Okay, and then I know I need to get 6 equal sized pieces. Well, I know that in order to get 6, I know 3 times 2 is 6, right? So if this had 3 pieces and this had 3 pieces, I would have a total of 6. So it's a great way to go ahead and kind of relate what we know about multiplication to help students to see that partitioning. So I'm going to go ahead and just partition each half into 3 equal parts. And then I always like to double check by counting. I have 1, 2, 3, 4, 5, 6 equal pieces. That means each of these pieces represents 1/6. So let's talk about that unit fraction of 1/6, because how much of the sandwich will each family member get? Well, friends, each person will get 1/6 of the sub sandwich, okay? We call this fraction a unit fraction. It is a unit fraction because it has a numerator of 1. Anytime our numerator is 1, we have a unit fraction, okay? So here I have a unit fraction. I know that the number 1 is called my numerator. And my 6 is the denominator. Now, they each have different parts of the whole, right? So the denominator is going to be the total number of pieces of how the whole is partitioned. So a lot of times we tend to refer to that denominator first because that tells us what our whole looks like, right? So here is my whole sub sandwich, but I can partition that whole in multiple different ways. I could partition it into fourths. I could partition it in half. But for this reasoning, I need to partition it into 6 equal sized pieces, which means that I needed to cut my whole into 6 equal parts. So then that I would know this one part is going to represent each family member would get 1/6 of the sub sandwich. Okay, so that's your area model. All right, we saw what it looked like with manipulatives, right? I'm gonna push those over to the side for us for just a moment. I might bring those back here. All right, so I could model the same exact problem, however, looking at what we know with number lines. Okay, so this sub sandwich, the way I think of it, it does kind of have a linear idea to it, right? But a lot of times you might see situations and you might want to model a situation with a number line if you have a distance from one point to the other. So when I am modeling with a number line, the part here that I have to make sure I'm representing is I need to show the one whole, right? I need to show where the whole is. So here I have my 0 and here I have the 1, okay? So that's my one whole. It's just like starting off with this one whole, right? And I could have made my number line to match that. You guys have magnetic fraction, so that would be great to model on the board with your magnetic fraction. So here I have my one whole, And if I need to partition it, I'm going to do the exact same thing that I did up here. I have to partition the whole into 6 equal pieces, right? So if I want to partition the whole into 6 equal pieces, I can again start with a half, right? So there's the 2 halves of my sandwich, and then I can partition each half into 3 equal parts. There's 1 part, 2 parts, 3 parts, 4 parts, 5 and 6 parts. Now, one really important part when it comes to working with number lines is knowing that we are counting the spaces here. So again, it might be great to relate your fraction bars to that number line to see what each interval represents, okay? So the distance from here to here, that distance represents 1/6, okay? Each distance on this number line has a value of 1/6. So this is 1/6, this space is 1/6, this space, and so on and so forth. And that's what we see when we line up all of our different fractional pieces, right? However, when I'm numbering on a number line, I count up starting with my unit fraction. So I could start by counting 1/6, and I'm going to count to 2/6, 3/6, 4/6, 5/6, and then 6/6. And I want to notice that 6/6 is equivalent to 1 whole. And I can prove that with my fraction tiles if I need to. But we're just going to go ahead and write that equivalency right below that 1 whole. So students see that 6/6 is equivalent to or equal to or the same as 1 whole. Okay. So each distance or each interval on this number line has a value of 1/6. Okay, so when you're working with your fraction models, always think about what fraction model would best suit the situation. This situation, you could either use an area model, or you could use a number line or a linear model. Okay, you'll see it, that vocabulary used both ways. But remember that we're talking about the distances in between those tick marks on our number line and making sure that students understand that we are counting the distances. So like this piece is for one family member, this piece is for another family member, and so on and so forth. Okay, so that is how we represent our unit fractions. Hey there, teachers. Let's look at an instructional strategy for AKS 4, IOA 4A. We've already looked at what unit fractions can look like. So now let's take a look at what a non-unit fraction might, how we could represent that. So let's start with the fraction 2/3. Okay, now again, when I'm given a fraction 2/3, I know that the 2 is my numerator, the 3 is my denominator. Fractions represent parts of a whole, okay? The denominator, in this case, our 3, tells us the total number of parts that our whole is partitioned. And the 2 tells us the number of parts, okay, out of that whole that we are working with. So in this case, it could be show that she walked 2/3 of the way home from school, and the distance home from school was 1 mile. Okay, so this fractional part, I have 2 parts of the 3 equal parts. Okay, so again, this is what we call a non-unit fraction. I know it's a non-unit fraction because my numerator is greater than 1. Okay, now again, I can use my manipulative pieces just like before. Okay, I can use my fraction tiles, my fraction squares, my fraction circles. I can also draw different area models, okay? So I could draw a circle. Maybe I'm representing that Ashley ate 2/3 of a pizza. So here I have my whole, my 1 pizza, and I need to show that Ashley ate 2/3 of that pizza. So I need to partition my circle into 3 equal parts. Now, teachers and students tend to not like to draw circles. I totally understand that. However, students might encounter where they have to interpret the fraction circle, right? But when you are partitioning a circle, give yourself a center, okay? That's always helpful here, just to know where your center is, especially if you're not just drawing a half, right? Because really halves and fourths are pretty easy. But when you're working with thirds and sixths, give yourself a center point, okay? So if I have 3 equal pieces, I'm going to do the best I can to represent 3 equal pieces. Okay, I have 1, 2, 3. I do note that that piece looks a little bit larger than that piece. I'm human, right? But if I use my fraction circle pieces, I can show how I can use those 3 equal pieces. And then if I'm showing 2 thirds, I'd want to shade in 2 of these pieces. Why? Because each piece of my circle has a value of 1/3. This is 1/3, this is 1/3, this is 1/3. So collectively, this is represented by 2 thirds. All right. When I am modeling fractions on a number line, okay, I want to make sure that I'm partitioning my number line. I first need to mark my 0 and my 1 whole. Okay, so to show 2 thirds, I need to show my 0 and my whole, and I need to partition the number line into 3 equal parts. Okay, so to partition it into 3 equal parts, I'm again going to do the best I can, and I'm counting spaces or intervals. So here's 1 spot, 2 spots, 3 spots. Again, I didn't do a very good job here. That one, if I could erase this, I would, and I'd be moving those tick marks over, okay? And so dry erase markers are so great to use when you're first learning how to partition. But in this case, yes, I only drew those 2 lines, but I'm looking at the intervals here, right? So I have this space, and this space. So each space has a value of 1/3. But as I count from 0, I go 0, 1/3, 2 thirds, 3 thirds. And again, I like to go ahead and write what that 1 whole would be written as a fraction, just to go ahead and start showing students that equivalency. And then if I want to mark 2 thirds, I would mark 2 thirds with a dot right at that spot, because I would know that 2 thirds would be, this is 1/3, that is 2 thirds away from 0. Okay, now one other thing that students might be asked to do, I'm going to move my camera a little bit. We might be asked to look at a number line. Okay, and I might be asked to look at distances on a number line. So let me just set up a number line for a moment. Okay, and I'm not going to tell you how my number line is partitioned, right? This happens a lot of times where students are just given a number line with the 0 and the 1. They're given a blank number line. None of those spots are listed, but they're saying, all right, this is point A, this is point B, and this is point C. Okay, what is the distance from point B to point C? Okay, what is the distance from point B to point C? So that was part of our standard, right? Because I'm looking at points on a number line, distances on a number line, okay? So if I'm looking at that piece right here, before I do anything with this number line, I need to know how the number line is partitioned. Well, how do I do that? Okay, I do that by counting the intervals between 0 and 1. Okay, I have to find the 1 whole. Sometimes when I work with fractions greater than 1, I might have tick marks here. I need to cover that up because I'm only looking to see how is the whole partitioned. I do that by counting the spaces. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 intervals or 8 spaces between 0 and 1. What does that mean? That means this number line is partitioned into 8s. So as I do that, I'm going to go ahead and label my number line. 1 8, 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s, 8 8s. Okay. Sometimes students might just be asked, like, point A, what fraction is located at point A? That would be 2 8s. What fraction is located at point B? 4 8s. What fraction is located at point C? 7 8s. Wonderful. But remember, what was our original question? What is the distance between point B and point C? What is the distance? Okay. So if I'm looking for the distance, I have this plus this plus this, right? Okay. So what did each interval represent? Well, each interval represented 1/8. So what is the distance between point B and point C? Well, because these are all eighths, the distance between is 1/8, 2/8, 3/8. So the distance between point B and point C is 3/8. So from B to C, or C to B, either way. Okay, I could also go backwards. Was the distance between C and A, and I could count those eighths. All right. Some students are going to say, oh, well, the distance is 7/8 because C is at 7/8. That's not true, okay? But I needed to know how the number line was partitioned in order to find out the value of each of those intervals, okay? So multiple different things that could be used with your non-unit fractions. I could use area models. I could use number lines. I could use the circle diagrams as an area model. I can also use the some students might also just partition a whole into 3 equal pieces like this, and I'm shading in, I'm going back to that 2/3 from earlier, right? Okay, so all the different ways to show our non-unit fractions, okay? So as you're looking through how this unit is paced, you'll see that students spend the first couple of days with unit fractions and all the different models, and then students will spend some time with non-unit fractions with all the different models before moving on throughout the unit. Hello, teachers. For this portion of the instructional strategies, we are going to take a look at how to model parts of a set when working with unit fractions and non-unit fractions. In 3rd grade, students are introduced to set models in which the whole is now determined by the total amount of objects. Any countable objects can be a set model. Set models can be confusing to some students because the whole is less obvious. The idea of referring to an entire collection as a single entity or whole makes understanding a set model difficult. In a set model, the whole is represented by the total number of objects. Let's take a look at the image on the screen to better understand set models. Here I have 8 color tiles. Here is my set of 8 objects. This entire collection is my whole. There are 8 objects in the whole. 8 could be a denominator that I use to represent the number of color tiles of a certain color. For example, how many of the color tiles are yellow? 4 of the 8 color tiles are yellow. So 8 represents the total number of objects in my set, or the total number of groups, and 4 represents the number that are yellow. I could write a fraction of how many are green, I could write a fraction of how many are blue, red, and so on and so forth. What is another way that I could use this set model to represent fractions? What if in this set I had 2 equal groups? I could take all of my objects and group them in these 2 groups. So this is my entire whole, but I have 1 group, 2 group. How many of the groups are yellow? 1 of the 2 groups are yellow. Okay, so notice, still the same number of color tiles, still the same number of objects in my set, but this time I grouped the objects in my set differently. Originally, the objects were grouped individually. Okay, let's look at a different grouping. Okay, actually, I'm going to switch these 2 for these purposes. Okay, again, what fraction of the set are yellow? So again, here is my whole, but now my objects have been grouped differently. Instead of 8 individual objects or 2 equal groups, I have 4 equal groups. How many of the groups are yellow? 2 of the 4 groups are yellow. 2 representing these 2 groups out of 4, which is the total number of groups in the set. Another thing that could be helpful for students is to actually draw circles around the groups. And this is great to do with a dry erase marker because then you can easily switch up how the items are grouped, okay? But using manipulatives like color tiles are a great way to help lay that foundation for how I analyze fractions or how I write fractions and represent fractions when I'm using parts of a set. Now let's take a look at this within a context. Ms. Smith brought 6 cupcakes from home to share with the kids in the neighborhood. 4 cupcakes were eaten. Fraction of the cupcakes did the kids eat? So again, here is my whole, okay? And one thing you could do to help students is to see the whole, is to actually put a grouping around it. That is my whole, okay? Each of these individual cupcakes represents one part of that whole. Okay, I have 6 individual cupcakes, which means that each cupcake represents the unit fraction 1/6. Okay, if 4 of my cupcakes were eaten, I could write the fraction 4/6 to represent the total number of cupcakes that were eaten from the set. 6 total in the set, 4 were eaten. This is when each cupcake is seen individually. Okay, now let's take a look at the same type of situation. Cupcakes, right? But this time they're going to be grouped a little bit differently. Miss Smith brought 6 cupcakes from home to share with the kids in the neighborhood. 2/3 of the cupcakes were eaten. How many cupcakes were eaten? So again, same model, but this time I need to organize my set differently. If I'm looking at 2/3 of the cupcakes were eaten. Let's write that fraction so I can see clearly. So 2 groups out of 3. How could I group these cupcakes to be in 3 equal groups? Well, I see these 2 as a group, these 2 as a group, and these 2 as a group. That means that each independent group, this is 1/3, this is 1/3, and this is 1/3, okay? If I want to show that 2/3 of the cupcakes were eaten, I'm talking about this group and this group. I have circled my 2/3 of my set. So how many of the cupcakes were eaten? 4 cupcakes were eaten. So same type of situation with just a little flip on whether or not I start with a fraction or end with a fraction, or if I'm given the total number of cupcakes that I am trying to find the fraction of within the set. But remember that I need to think of ways that I can group them equally. And also remember that it is the first time students have really worked with parts of a set. So using manipulatives like our color tiles is going to be a great way to help students make connections with the images that they see. They're great teachers. Let's take a look at another instructional strategy. Again, for AKS 4, this time we are going to focus on IOA 4C, representing fractions, including fractions greater than 1 in multiple ways, area models, set models, linear models, etc. Okay, so I have this fraction 5/4 that we are going to work with today. Now, again, we know that the number that is above the fraction line, this is our numerator. And the number on below the fraction line is our denominator. Denominator. Okay. long word to spell. All right, so here we have force. In this fraction, if I were to show this fraction to students, students might say, well, that's interesting. The numerator is larger than the denominator, and they are correct. It is okay that a fraction has a numerator larger than the denominator. What this tells me is that the whole is still going to be partitioned into 4 equal pieces, but this time I need 5 of those pieces. So I need 5 fourths. Now, one thing to note, we do only call these types of fractions that are greater than 1 because the numerator is larger than the denominator. That's how I know it's a fraction larger than 1. Okay, so I can represent this fraction in a couple of different ways. Okay, so if I want to represent this fraction using manipulatives, I know that my whole is partitioned into 4 equal parts. So if I think about this one whole, and if I am partitioning into fourths, I know, and students might also realize that, hey, one whole has 4 fourths, right? But I am supposed to represent 5 fourths. So in that case, I am showing my model that has one piece longer than the one whole. It's a great way to show students how this fractional value is larger than one whole or greater than one whole. So I am showing 5 fourths because here are my individual unit fractions. Okay, and this fraction is made up of 5 1/4, 1/4, 2/4, 3/4, 4/4, 5/4. I can count those to know that that matches that model. Okay, now I can also show this same fraction, this fraction greater than 1, as a mixed number. It is okay to introduce that vocabulary to your students. This is what we call a mixed number. It is a mixed number because I have a part that is equal to a whole plus a little bit more. Okay, so if I wanted to write 5 fourths as a mixed number, I have to look at that fraction 5 fourths and know that it is the same as 4 fourths and 1/4. Okay, notice that I only want to decompose my fraction greater than 1 into the part equal to the whole, and then the amount that's a little bit more than the whole. You can also use a part whole diagram to support your thinking. So here I have 5 fourths. And I know that 5 fourths has 4 fourths and 1/4. Okay, and I can very clearly see that with this model here, right? So if I want to write this number 5 fourths as a mixed number, well, I know that 4 fourths is equivalent to 1 whole. So I could say that 5 fourths is equal to 1 and 1/4. Okay, because all I did is replace that 4 fourths with the number 1 whole. And we call this a mixed number because it is made up of a whole number part and a fractional part. Okay, and the models are really going to help students to make that connection to where I could just replace the 4 fourths with 1 whole. And it's a great way just to lay it on top there so they do that, see that equivalency, and then I have that 1/4 left over. Okay, I could also be given the mixed number 1/4 and have to show that as a fraction just greater than 1 with a numerator larger than the denominator. Okay, so what that would look like if I wanted to draw it. So let's just say 3/2. Okay, I want to represent 3/2. Oh, I did it the wrong way. Just kidding. Let's pick a new one. Ready? I want to show 1 and 1/3. Okay, 1 1/3 is a mixed number. I know it's a mixed number because it has a whole number part and it has a fractional part. And I want to show that as a fraction just greater than 1 with just a numerator and a denominator. So here, teachers, we want to make sure that we do anchor this in either the manipulatives where students are building it or by drawing a representation. So if I want to represent 1 whole and 1/3, I would show 1 whole. Right? There's my 1 whole. But think about, how does my whole need to be partitioned? It needs to be partitioned into thirds, right? So here I have 1 whole, but I need it partitioned into thirds. And there's my 3/3. And then I need 1 more whole. And I'm going to again partition this into thirds, but I only need 1 more. So by drawing it this way, I see this model is worth 3/3. This model is worth 1/3, but I could also count 1/3, 2/3, 3/3, 4/3, and know that 1 1/3 is the same as 4/3. So students may have to represent fractions either from just written as a fraction greater than 1 with just a numerator and a denominator and write it as a mixed number, or they might be given the mixed number and need to represent that mixed number as just a fraction. And they could do that by drawing area models. They could also use the fraction tiles, the fraction squares, or the fraction circles to support their thinking. Because again, we are working on showing multiple ways to represent fractions, including fractions greater than 1. So you could also spend some time looking at fractions equivalent to 1 here, and that'll help as you moved into equivalent fractions. Hey teachers, one of the last instructional strategies we are going to take a look at today deals with AKS 4, IOA 4D, recognizing and generating simple equivalent fractions. Now again, we are only working with fractions that have denominators of 2, 3, 4, 6, and 8. So that's very important to note. However, as students are exploring, they might find, oh, fifths are equivalent to tenths, and sixths are equivalent to twelfths, and so on and so forth. Of course, we do want to encourage that kind of thinking, right? But one thing to note is when you are working with fractions at your small group table or making decisions on what problem you will model or use in your assessments, just please be aware of the appropriate denominators to use, okay? We're going to use this situation today to help us just kind of look at a few instructional strategies to use when working with equivalent fractions. So you've probably, when you get to this part in the unit, you've probably used that word equivalency at some point in time, because as we've worked with number lines, especially, we've shown how a number like 4/4 is equal to 1 whole. We also have already worked on showing how fractions greater than 1 can be equivalent to a mixed number. So you have already kind of touched on this idea of equivalency, but here is you're recognizing and generating the simple equivalent fraction. So let's take a look. I believe this is from a formative. Which 2 ugly dolls are thinking of fractions that are equivalent? You have Lucky Bat is thinking of 2/8. The Ice Bat is thinking of 1/4, and Moxie is thinking of 2/4. So, of course, we would always want to start with our manipulatives, right? When we're using fraction tiles here, or the fraction bars, either way that they're called, I tend to like to use these fraction bars for equivalency, because you can really kind of show like kind of the progression of how the fractions are, how they look equivalent to each other in reference to 1 whole. Okay, so anytime I work with that, I always like to make sure I'm bringing out that 1 whole. So let's show Lucky Bat. She is, she's thinking of 2/8. Okay, so I would build that there. Ice Bat is thinking of 1/4. So I'm going to line that up right here. And then finally, Moxie is thinking of 2/4. Now we know one common misconception is that students will say, oh, that's a 2 and that's a 2. So those are equal, because students are only looking at the numerators and not realizing that the denominators are different. And remember that the denominator tells us how the whole is partitioned, right? How many equal parts are in our whole. And then our numerator tells us how many of those parts do we need. Okay, so we have Lucky Bat with 2/8, we have Ice Bat with 1/4, and then we have Moxie here with 2/4. So when I line all of those values up, I can clearly see that 2/8 of Lucky Bat is the same as Ice Bat of 1/4. So I can write that equivalency to show that 2/8 is equal to 1/4. Now, something students might also note, because you've taught comparisons before you've worked with equivalency, they might notice that 2/4, Moxie's value, is actually greater than the other two values. Even though we only compare unit fractions in 3rd grade, that's still a great noticing, okay? That Moxie's value is more, and I can tell that in my model, okay? Now, we know we won't always have those fraction manipulatives. So how can I draw area models, right? So when using area models, I want to show Lucky Bat. So I'm just going to use an L, and I want to represent 8s. So if I want to represent 8s, I need to partition the whole into 8 equal parts. So here I have halves, right? I have 2 halves, and then I'm going to partition into 4ths. I have 4 equal pieces, and that tells me something here, but I'm not there yet. So now I need to go to 8. So I'm going to partition each 4th in half to get a total of 8 equal pieces in my whole. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I've partitioned my whole into 8 equal parts. And Lucky is thinking of 2/8. Okay? So I've shaded in her or his value of 2/8. Lucky's, we'll just say, Lucky's value. All right, now I'm looking at Ice Bat. So I'm going to use an I. Now, when I am generating or recognizing simple equivalent fractions, I am almost in a way comparing, right? So I am going to draw a whole because they're thinking of the same size whole. So my whole needs to be about the same size. Okay, so it's very important there. I don't want to draw this whole really huge, because then it's going to be harder when I am trying to compare the values. Now remember, when I first started drawing Lucky's picture or Lucky's whole, I did start with 1/2. So I noticed that was my 1/2 spot right there. And I know that because 4 are on this side, 4 pieces, and then I have 4 pieces. So I'm just going to keep going and recognizing that that's my 1/2. Okay. I need those pieces to line up, right? So now I've got Ice Bats are 4ths. Now, remember, I was able to do halves here because this is a 4th. If this number was a 3rd, I would not be able to start off with a half. Okay, so that's something else to help your students notice that relationship between halves, 4ths, and 8ths, and then the relationship between 3rds and 6ths. Okay, so that's an important piece you can help point out to your students. So now if I want to show 4ths, I know that my equal pieces would be there. Okay, so now I need to shade in one of the 4 equal pieces. So there's Ice Bats. And then finally I have Moxie. And I'm again, that hole looks a little bit longer that way, but that's okay because I'm doing the best I can. But this also has to be partitioned into 4, so I can make the model look exactly like the one above. But this time Moxie wanted 2 pieces shaded. Okay, so there was my 1/8, here's my 1/4, and here's my 2/4. And again, shows the same thing. I noticed that with the area model, both of these pieces only go to about there. Those 2 bats or ugly dolls, I'm sorry, those 2 ugly dolls were thinking of equivalent fractions, and Moxie's was not equivalent to it. Okay. Now, when using a number line, in this case, because I do have 3 different characters in my situation, I would need to draw 3 number lines. Now, when I draw the 3 number lines here, okay, I need to remember that if here is my 0 and here is my 1, I need all 3 number lines to start off on the same exact spot. So one thing you could do, okay, I'm going to draw a straight line to show, hey, that's all my zeros, and then here's all my ones. They're going to kind of run together, aren't they? But there's my 1, okay? And then as I draw my different pieces, again, if here is the Lucky Bats doll, Lucky Bats, here's his fraction. That name is going to drive me crazy. And when I want to show 8s, again, when I'm partitioning my whole, I want to make sure that I start off with a half in this case, because I know 8s can be partitioned into 2 equal groups. And then I have fourths, and I'm going to say, there's my 4. So I'm going to go ahead and partition both of my other fraction models for Ice Bat and for Moxie at 4ths, okay? But I'm going to stop there because I know Lucky now has to be partitioned into 8ths, so that number line is partitioned a little bit further. So now the important thing to note is that when I am labeling it, this number line has to be labeled by 8ths. Oh, 8/8. Okay. And then this number line and this number line are both labeled by 4ths. And I probably should have used a different color. That's okay. But just make note of that when you are drawing it, okay? Now, before I even plot the values on the number line, I see that all of these pieces are equal to 1/2, which that is true. 4/8 is equivalent to 1/2, and so is 2/4. And then I see 2/8 is equivalent to 1/4. I also see 6/8 is equivalent to 3/4. So the number line here is very powerful whenever you show it stacked right on top of one each other. Now, in a number line, though, I want to plot the points. So 2/8 is here. 1/4 is here, and 2/4 is here. So the distances on a number line, you're looking at the distance from 0. So this distance is the same as this distance, which are both less than this distance, okay? So the reference point here was 0. Now, sometimes I might be looking at fractional parts on a number line when I don't start at 0, and remember, I still need to just count those intervals. But in this case, I can see that 2/8 and 1/4 are equivalent because they are the same distance from 0 on my number line. Okay, so again, we want students to use the model that is most efficient for them. However, it is important that students have seen the different models and that they can interpret the different models as they are recognizing and generating those simple equivalent fractions. So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview. Thanks again. We appreciate you watching.